So we're going to look at joints. There's actually no such thing as a joint because there's actually two types of joints. And it's all up here in the Assemble tab. You have really two types of joints. You have joint and you have as-built joints. Now, they did bring in another one a few years ago, which was called duplicate with joints. But technically, as far as Fusion is concerned, there are joints, and the shortcut for that is J. And then there's as-built joints, which is Shift J. So this is from the Autodesk website. The joint tool lets you position components relative to one another, then define the relative motion between them. Use this tool when the components are not yet positioned relative to each other in an assembly. So let's assume this, what we're looking at now, is an assembly, but it's not been assembled because these I want to put in these little holes and that I want to put in that bit there and whatever. However, there is another thing called an as-built joint. Now, this one, what I'm going to do, I downloaded this from the internet. It's not a Fusion file. This is a, I don't know, step file or something. I don't know what it's called. But I can give you the link to this. And this has obviously been built in situ. So this is a clamp. But fundamentally, all these parts, although they look like they're all joined together, you kind of realize that they're not joined together, but they were built as if they were all together. So let's start off with joints. Now, the thing with joints, you have to do it in a specific order. So again, this is from the Autodesk website. The order in which you select components determines the position, direction, or the positive direction for joint movement. The first component you select, let's say component 1. So if we're looking at, say, this one here, that's the first component. Rotates around or moves along an axis in the direction of the degrees of freedom arrow relative to component 2. Well, that makes sense, doesn't it? So let's just do it anyway. So going up here, we have joint. So that's one way of getting to it. We've got assemble, we've got joint, and then we've got the shortcut J. So when you do joint, the first thing it will ask you to do is select, what does it say? Select a snap point on component 1. Now, a snap point is what Fusion determines is a point that you may use as the center of origin for the snap. So we have here, which is obviously the front face. We've also got like these little edges and all different bits and pieces. However, if you just come down here, you'll notice once you get near, it snaps. And if it looks a bit fuzzy, that's probably because it's inside that cylinder is a snap point. And that's what I'm going to use for the first one. I'm going to select that one. Now, the next thing that you want to select is what kind of motion do you want? Now, with the motions, we've got 7. We've got rigid, revolute, slider, cylindrical, pin slot, planar, and ball. So for this one, we're going to use rigid. And then on the position, what we need to do now is we need to decide where we want component 1 to go to. So I've made a little block thing here. Now, what again you'll notice is when I select a face, you're going to see what they call origin points. And it's bits where you could bring that middle point to. So on here, we've got obviously the middle there, the middle there, the middle there, blah, 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 blah. Now I want it to go in the middle of this tube. Now I can see the middle of that tube. So if you have a look, it's kind of gone a gray color. Zoom in a bit on that. It's gone kind of a gray color. So the bit that I want is, oh, that's a bit annoying, isn't it? The bit I want is, keeps disappearing. The reason it keeps disappearing is because it assumes that you're moving over to this face. So when you're here, if you're clever and you use a Mac, you'll use the command. So if you hold down the command button, what that does is that locks that face. So regardless of, oh no, it didn't. Why didn't it do that? Right. If I do it to there, wherever I try and take the mouse, it won't select any other faces. It will just either select the front of that hole, the middle of the hole, or the end of the hole. Now, obviously, if you're not clever and use a Mac, you can actually use Control on a PC. So if I select that one there, what you'll notice is that cylinder has shot from there and it's gone into there. And the motion is rigid. Now, rigid, you have a thing called here where you can preview the motion. If you click that, click it again and it'll stop making that crazy little rattling. A rigid is just like an earthquake type motion. What it means is it's been physically welded, stuck, glued, jammed in, whatever you want, into that position. That's a rigid joint. Let's have a look at some other joints then. So if we go to up here, we do joint. So we had rigid. The next one is a revolute. So if we go over to this here and we select that midpoint of that cylinder and we go over to here and again hold down the command or control and select the middle point of that one. This motion is a revolute. So if we, I'll just zoom in a bit so you can see it a bit better. So if we preview it, you'll notice that revolute is just where it will revolve around and around and around, depending on what axis you select there. Okay, but at the moment it's selected around that axis. Now you will notice that it's Z. Just don't worry about it. We'll worry about that another time. Okay, so that's okay. I'm happy with that. So we've done rigid and we've done revolute. So let's do shortcut J. The next motion we have there is slider. So we can do exactly the same for position. We go into the center point of there, come over to here, command or control, select that middle one. And then if we go on to motion and we do preview, you'll notice that that's a slider. It slides in and out of the hole, depending on, again, which axis you pick. Okay, next one, assemble joint. So that was slider. The next one, cylindrical. Go over to position and we make sure we're at the middle point of that one. Come down to this hole here, command, select the middle. And one little tip is when you want to preview it, it's going to just do the revolve. But if you do all limits, it will do the revolve and the slide. So cylindrical is a rotate and a slide. Probably particularly useful, say, like on a screw, because a screw would unscrew and lift in and out. That's that one. Next joint is a pin slot. So if we go again to position and we go to the center point there, and if we come up to here, again, with this, we can select any of these faces, but if we select that inside face there and hold the command or control, I can select the middle point of there. And this is a pin slot. So a pin slot rotates and slides. So let's have a look at that one. So let's preview that one. So if you can see, it's rotating and it's going backwards and forwards in the slot. Now, the only thing that's happening with this, which is a bit weird, is it's obviously going through the material. Well, obviously in the real world, it wouldn't do that. Now, the other thing that you've got on joints is you have what they call motion limits. Now, because this has two motions, it has a revolve and technically a slide, you can set the limits on the rotate, but really what we want to do, because obviously it will rotate within that slot, that's not a problem, but the slide does need to be limited on its axis of movement. Now, because I made this, I know that on here, the minimum is 0, because that's the 0 position. And I know that this here is 100 mil, is the maximum amount of movement that it's got. So what I can do is if I put into there 100, you'll see now it's gone down to the 100 mil position. You also have another thing here, which is what they call rest. Now, rest is where you want it to sit when it's not, it's minimum or maximum. So we could, on that one, maybe put 50 mil. So that sticks it in the middle. So if we now preview the limits, what we'll notice now is it will then slide in that slot from 0 to 100, and it will rotate around, which is what it would do. What we're doing is we're simulating what the real material would do. Okay. And let's do another joint. So another joint we've got is, what's the next one? Pin slot planer. Now, planer is a bit of a weird one. It's probably easier to show you than try and explain to you how to do it. So with planer, if you select the position on the first piece, so this is just a hexagonal bit of material. So we're going to select the middle part of that face. And then if we come up to this face, I think logically would be to just put it there. Now, planar, if you can kind of imagine, means that you are locking two planes or two planar surfaces together as if they were magnetically connected. So on this occasion, if we do the motion and we preview, one thing you'll notice is that this thing rotates, but it has two, if we take all the limits off, the first motion that it has is a rotate, so it can spin around and around and around, and it has two slide directions. So one slide direction is that way, and the other slide direction is that way. So it gives you full freedom of movement, excluding one plane, okay? And that's where we have the selecting axis is perpendicular to the plane to slide along. But if you imagine it as it's kind of magnetically attracted two surfaces together, the thing can do whatever it wants, but it can't separate from that magnetic touch. Well, that's okay. I think we've just got one more, and then I'm going to have a breather. So we've got another joint here, and the final one is, get out the way, is a ball. So a ball is a ball and socket joint. So again, if we select the ball there, well, theoretically a ball only has one point of origin, which is obviously the center of the ball. And then if we come over to component 2, and if we just go to the center of there, which would be the center of the ball, we can then, with the motion, we can then preview that motion. Now at the moment it has pitch, so that's what we're viewing. It has yaw, which is that way round. And then obviously we have the roll, which is that. So when we look at the all limits, it's kind of the crazy ball joint. Now this one is definitely going to need a motion limits, because it wouldn't go through the metal, would it? So you have exactly the same here. When it comes to the pitch, that's, oops, sorry. If you have this all limits selected, it will show you all axes of movement. So with the pitch, I'm completely happy with that. I don't really need to change anything. With the roll, again, I don't need anything to do with that one. But clearly with the yaw, I have a problem, because that's going physically through the metal or the wood or whatever it is. So what we need to do, the minimum being 0, well, I think that's right, because the minimum is sticking right up. So the maximum, I'm I don't know, let's pick a really good number. Let's say 69. So let's see 69. Is that a good number? Yeah, I think that's pretty good. So that shows that will go down to 69. So if we do the all limits now, and we do a preview, what you'll notice is that it will now not go through the material, which in the real world it wouldn't do.